Okay, how's it going, everybody? There are exciting news from the world of fish biology, which I saw just today when I was drinking my morning coffee. So, there is a new paper out by Sheahan. I hope I did not mispronounce the person's name. And the paper is about the coelacanth and the coelacanths range of biogeographic distribution. Now, this is very exciting, and so that you can share my excitement, I have to explain a few things. So please bear with me. First of all, what's a coelacanth? So a coelacanth is a large fish which lives in the tropical oceans. Particularly, there are two species, one of the east coast of Africa and one in Indonesia. But this is not a conventional fish like your trout or your goldfish, which are bony fish, or like your shark. It's a completely separate class of fishes. In fact, it's more closely related to a salamander or even to you and me than to, the trout or the goldfish. So the coelacanth is a relative of the first fishes, of the lobe-finned fishes, which in ancient times became land mammals, where these lobed fins evolved into land appendages, into legs, and then they moved onto land. So this big step in evolution started with an animal very similar to a coelacanth. Now, for the longest time, people thought the coelacanth was extinct. But I believe in the 1930s in South Africa, a single individual was found. So this was a huge scientific discovery. People had thought, scientists, everybody who cared, thought that this coelacanth had been extinct for about 60 million years, but there it was. So why was it found so late, relatively speaking, in the history of fish biology? Well, because there are not that many of them, because they're large and they live really deep. So what they do, they hide in caves between 100 and 250 meters during the day, and then they dive even deeper at night to hunt, and they hunt for fish. And so this new paper, what does this say? So they did a species distribution modeling study, meaning what you do is you take what's known about the species in terms of what environmental parameters does it need. So particularly in terms of the environment of the coelacanth, what they did, they looked, how deep does it have to be? What can the water temperature be? So there is, when it's warmer than about 26 degrees Celsius, there's not enough oxygen in the water, in the seawater, for the coelacanths to live. So, what are the correct parameters where the coelacanths can live? And then they plotted that on a map of the Indo-Pacific, and they predicted where this animal would potentially be found. Now, something like that had been done previously. What is new and improved in this study, which just came out, is that they also looked at these parameters in 3 dimensions. So not just did they look, where is it warm enough and where is the ocean just right, so they also looked at the depth dimension. And that came to the conclusion that the coelacanth could have a wider range than previously suspected or expected. And to quote the authors in the discussion, they say the islands of the Philippines from Luzon to Mindanao are predicted to host coelacanths suitable habitat largely between 100 and 250 meters and remain connected to Sulawesi throughout that depth range. So not just is the habitat which is suitable in the Philippines, but the species, the coelacanth species from Indonesia, could have a continuous path to spread to the Philippines. And so they are again stressing that the coelacanths prefer volcanic caves, underwater caves of course, as daytime shelter. And these are abundant, of course, in many of these volcanic islands of the Philippines. So, what is the conclusion here? Somebody should take a ROV, a remote operated vehicle, essentially a remote controlled submarine, and look for coelacanths in the Philippines. And the chances that they're here are probably pretty good. This to me is exciting. I hope I conveyed some of that excitement to you.